Hi guys, thank you for watching my previous videos. So today we are looking at a new chapter called Trigonometry 1. So since we have Trigonometry Part 1, so definitely we will have Trigonometry Part 2. But that will be our next chapter. Today only we are looking at Trigonometry 1. So we have come to the new slide. So we are given that secant theta equals to 17/15 and theta is an acute angle. What it means? Less than 90 degrees. And we are asked to find the value of each of the following without using a calculator. So this question asks us to do without a calculator, so you can't use a calculator. If you use a calculator, you get 0. So secant theta equals to 17/15. That means 1 over cosine theta is equal to 17/15. And that will give us cosine theta equals to 15/17. So you have to know that secant theta is equal to 1 over cosine theta. So with this, what we need to do, we just need to draw a right angle triangle. And remember that the abbreviations to, ca, so. So what it means, let me go through again. To, tangent theta equals to opposite over your adjacent. For car, you have cosine theta equals to adjacent over your hypotenuse. So therefore you see adjacent over hypotenuse. Okay. Last but not least, so you have sine theta equals to opposite over hypotenuse. So therefore, with this to, ca, so, and their respective formulas on your right, so you can clearly see that cosine theta equals 15/17. It is adjacent over hypotenuse. So let me label adjacent, opposite, and hypotenuse in this right angle triangle. So cosine theta is adjacent over hypotenuse, and therefore you get your hypotenuse to be 17 and your adjacent to be 15. So with this, so we can find our part 1 sine theta. Sine theta is opposite over hypotenuse because it's so. Therefore, in this right angle triangle, we have to find out what is our opposite. So for a right angle triangle, you know that we can use Pythagoras theorem. Opposite square plus adjacent square equals to our hypotenuse square. And we are using Pythagoras theorem here. So let me sub in the values. Opposite is what we need to find. Adjacent is 15, hypotenuse 17. Sub it in, you should get your opposite to be plus or minus 8. And we only take in plus 8 only. So I will write down 8 in the diagram. So therefore, we have opposite over hypotenuse or sine theta. Therefore, your sine theta is 8/17. And by the way, theta is an acute angle. Therefore, it is positive for cosine theta, sine theta, and tangent theta. Next, we are asked to find tangent bracket 90 degree minus theta. That means is the other angle in red. Therefore, tangent is opposite over adjacent. So your opposite is 15 now, and your adjacent is 8 because of the angle in red. So you get 15/8 for tangent bracket 90 degree minus theta. Now, cosine bracket 180 minus theta. By the way, this gives you minus cosine theta. And therefore, it's just negative what you get previously. Because cosine theta is 15/17, therefore minus cosine theta is minus 15 over 17. So the summary here, you have to know Tokaso on the right. Now we have come to a new slide. It says find all the angles between 0 degree and 360 degree inclusive, which satisfy the equation below. So which means your x is from 0 degree to 360 degree. They are both inclusive. And now let me copy this equation down. Find sine square x minus 6 sine x cosine x equals to 0. So our job here is to, because we see sine x here and we also see cosine x. So our job is to make it either sine x or cosine x in this equation. We can't have both. If we have both sine x and cosine x, we can't solve. It's just like if you have x, you have y, you have one equation, you have two unknowns, it's impossible for you to solve. So therefore our job is to make it into an equation with only sine x or cosine x only. Okay, so what I do first is take out the common factor sine x. So once I take out sine x, I get bracket 5 sine x minus 6 cosine x. So clearly you have your 5 sine x minus 6 cosine x equals to 0 and sine x equals to 0. And sine x equals 0, if you remember the curve, sine x equals 0 is when x is equal to 0 degree, 180 degree and 360 degree. Okay, so in fact I will draw the normal cosine curve for you to see and label it. Therefore your x is 0 degree, 180 degree and 360 degree when your y is equal to 0. And now let's look at 5 sine x minus 6 cosine x equals to 0. Okay, so for this question, I need to divide by cosine x on both sides. As I've said before, you can't have sine x and cosine x in one equation. You can't solve with sine x and cosine x in one equation. Therefore, I divide by cosine x, and therefore 5 sine x over cosine x, I get 5 tangent x minus 6 equals to 0. Therefore 5 tangent x equals to 6, and therefore tangent x equals to 6 over 5. So now I can continue to solve my x. And in fact tangent x is equal to 1.2. And now let me introduce a new concept here. So we have 4 quadrants: A, S, T, C. And with these 4 quadrants, I will write down the formulas for each. So for quadrant A, theta equals to basic angle alpha. For quadrant S, theta equals to 180 degree minus alpha. For quadrant T, theta equals to 180 degree plus alpha. While for the last quadrant C, theta equals to 360 degree minus alpha. So for tangent equals to 1.2, tangent x is positive now. So the quadrant we should look at is our A quadrant and T quadrant, because only in these 2 quadrants, A and quadrant T, we get tangent positive. And therefore the formula you should use is, since we have chosen quadrant A and quadrant T, the formula we need to use is theta equals to alpha, or theta equals to 180 degree plus alpha. So let me go ahead and find out what is x. X equals to tangent negative to the power of negative 1, 1.2. You should get 50.19 degree. And this is your alpha from quadrant A. So next, since you know your alpha, which is 50.19 degree, therefore another formula from quadrant T is 180 plus alpha. Okay, so now let's proceed to use the formula in the quadrant T. Theta equals to 180 plus alpha. So therefore theta equals to my x 180 plus my 50.19. Therefore, take out your calculator, you should get 230.19 degree. So therefore, you have found out your x. We have 5 answers here. 2 from our solution of tangent x equals to 1.2, 3 from our sine x equals to 0. So now I'm trying to make it easier. Okay, next we have this question. We are asked to find or sketch the curves y equals to 4 sine x plus 1 and y equals to 2 cosine x. So before that, let me introduce you to a general form. Y equals to a sine bx plus c, and we will go into very deep details as how this a, b, c affects our sine curve. So let me do it first. But before that, I should draw out the y-axis and our x-axis first. And you have seen I have drawn out my y-axis and my x-axis, and have labeled the axis as well. So we are asked to draw for the interval 0 to 2 pi. So over here is 0 to 2 pi only. So what we need to do first, let me try to use a tool to help me draw this sine curve. Or rather, the tool is not that useful. Let me use freehand. Okay? Because I find that freehand is easier for me to demonstrate here. Okay, so let's label all the required points. Your sine curve, as you know, it starts from 0, it goes to 1, come back to 0, goes to -1, goes back to 0. So I have these points marked out. So my job is to link them up. Let me see if I can use a tool to help us draw it nicely. Okay, I think I've drawn the curve, and let me link it up. So it appears. However, it does not look proportionally, and it does not look like a real sine curve. It looks like a sine curve, but it's not a very good sine curve. Let me do it again by using freehand. So it does not look perfectly. However, you should get the idea, or you should get the gist of this question. Okay, let me redraw it one final time because I don't wish to waste more time on drawing the curve. So now let me draw it carefully and link all these points up to get our sine curve. Okay, done. I have drawn my normal sine curve, which is y equals to sine x. Remember, every time you have finished drawing a curve, you have to label the curve. So this is our very basic y equals to sine x curve. And now let's see, because we are asked to draw y equals to 4 sine x plus 1, right? And now let's start drawing y equals to 4 sine x first. So this 4 in front of sine x, what it means? It means it will 4 times every value. So when I have 0, I get 0. When I have 1, I get 4. When I get, therefore, I have also marked all the points for this. So let me link up all these points to get my y equals to 4 sine x. The graph is in green for y equals to 4 sine x. Okay, so let me change y equals to 4 sine x to green color, so that each color matches its equation. And now let's add in plus 1, and this y equals to 4 sine x plus 1 is what we are asked to find or asked to sketch, in fact. So with a plus 1 at the back, that means every value we should raise it by 1. So at 0 we get 1, at 4 we get 5, at 0 we get 1 again, at minus 4 we get minus 3, at 0 we get 1. So let me start plotting, or let me start marking out all these points. By the way, I'm using black color here. So I have finished. So my job is to link up all these points. After linking up all these points, that is the curve we are asked to sketch. And the curve is in black. And therefore, your curve y equals to 4 sine x plus 1 is drawn. And basically, if you are good enough, you just have to show the last curve, which is y equals to 4 sine x plus 1. The rest, you can simply skip it. But for demonstration purpose, I would like to show you how I reach the curve y equals to 4 sine x plus 1. So with software, I can easily erase it. So now let's continue to draw a normal cosine x equals to y curve. So I have drawn in red my y equals to cosine x. This is my basic y equals to cosine x graph. And now we are asked to find 2 cosine x, right? So that means each value you have to times 2. 1 gives you 2, 0 gives you 0, minus 1 gives you minus 2, 0 gives you 0, 1 gives you 2. So as you can see, my y equals to cosine x is blocking me. So what I can do, let me shift it to somewhere that does not hinders me. So with software, it's easy. I don't have to erase it, I just have to move it elsewhere. Yep, I've done it. So now I can mark out my last point, 2. Well, my x is 2 pi, and therefore let me link up all these points so that I will get y equals to 2 cosine x. I will use gray color here to differentiate all the different graphs. Okay, so after I finish drawing this graph, I should label the graph. So now what I need to do, I need to erase all the unnecessary graphs. What I need to do, just show the two curves we are asked to sketch. And now my whole graph or my whole diagram looks very tidy and neat, right? Because I only have the two required graphs. And now let's take a look at the number of solutions in this interval. For the equation 2 cosine x equals to 4 sine x plus 1, so clearly you see two intersection points, which I use blue to highlight it. So if there are two intersections, therefore the number of solutions is 2. So we have two intersections, we have two solutions. So the number of solutions is 2. Okay, it should be easy for you, right? Next, the question says the diagram shows a right angle triangle ABC in which AB equals to x, labeled. Angle ACB is 30 degrees, labeled. And angle ABC is 90 degrees, labeled. The point D lies on BC such that 3BD equals to 2DC. Okay, so I can also label my angle BAC equals to 60 degrees. And it says 3BD equals to 2DC. What it means? It means DC over BD equals to 3 over 2. So I can also label this ratio in the diagram. BD is 2, DC is 3. So now we are asked to show that angle CAD equals to 60 degrees minus a tangent to the power of -1, bracket 2 square root 3 over 5. Okay, it looks really complicated, but never mind, let's do it step by step. So angle CAD is nothing but 60 degrees minus my angle BAD, right? So the angle CAD is already in red. So angle CAD in red is actually equal to 60 degrees minus my angle BAD, which is highlighted in yellow. So my job is to find what is angle BAD. Okay? So don't care about the question that asks us to show. Let's find what is angle BAD first. And let's see how we can find angle BAD. So now let me extract the triangle ABC out first. So I have already extracted this triangle ABC out with AB equal to x. And in triangle ABC, you should see that tangent 30 degrees equals to my opposite over my adjacent, which is x over BC. Remember Tokaso. And therefore, your BC is x over 1 over square root 3. Tangent 30 degrees is 1 over square root 3. Some of you might not know that tangent 30 degrees is equal to 1 over square root 3, but don't worry, I will explain it later. So BC is equal to square root 3x cm. So why tangent 30 degrees equals to 1 over square root 3? Okay, let me draw a right angle triangle out with 30 degrees. And my base is 1, and the hypotenuse is 2. and therefore because of Pythagoras theorem, you get your height equals to square root 3. And therefore, and you might be wondering, why square root 3 is my height? Use Pythagoras theorem, 1 square plus bracket square root 3 to the power of 2 equals to 2 square. And I have highlighted it color by color so that you can see. This equation is valid. This Pythagoras theorem equation is valid. Therefore, tangent 30 degrees is opposite over your adjacent. Therefore, it's 1 over square root 3. That's why 30 degree, tangent 30 degree, you get 1 over square root 3. So I have found BC here. So if I know BC, BD is actually 2/5 of square root 3x because of the ratio above. Okay, so let me continue. So BD is actually 2 square root 3 over 5 x cm. And now let me extract another triangle ABD. So in triangle ABD, I know that my AB is x and my BD is found now, which is 2 square root 3 over 5x. So we are asked to find triangle BAD, right? So again, use tangent triangle ABD. I'm sorry, I'm wrong here. I will correct it. It should be BAD equals to BD over my AB, which is 2 square root 3 over 5. So therefore, angle BAD, not ABD. So angle BAD. So you can see I am editing my mistake now. So angle BAD equals to 2 square root 3 over 5. So I'm labeling in the diagram so that you can see clearly which one is my adjacent, which one is my opposite. Okay, so therefore you can see that square root BAD, triangle BAD is tangent to the power of -1 to square root 3 over 5. Right? Therefore, you just sub in this angle BAD into the one labeled in yellow. You get angle CAD equals to 60 degree minus tangent to the power of -1 to square root 3 over 5. So we have shown. Right? So without further ado, let's go to the next question. So what we have here, we have a question: the population of mosquitoes in a particular district is primarily influenced by precipitation, humidity, and temperature, and is modeled by the function given. P is the mosquito population in thousands in week T of the year. Using this model, we are asked to find the period of function. So period is equals to 1 over F or 2 pi over B. But in the first place, you need to know what is B in a given cosine function or sine function. So let me copy this cosine function down first. So the cosine function is P equals to 50 cosine bracket pi over 25t plus 900. So in this cosine function, your A is your 50, your B is your pi over 25, and your C is 900. And therefore, sub in my B into 2 pi over B, which gives me 2 pi over 25. This gives me, you can use your calculator, this gives me 50. And T is in period, the T is in week, right? So therefore, the period of the function is 50 weeks. So with this, we are asked to sketch the graph of the function over one period. And therefore, our period is 50 weeks. Therefore, your period should be 50 weeks. That means you should draw from 0 week to 50 weeks for the graph. So now let's draw your vertical axis and your horizontal axis, and label your horizontal axis from 0 to 50 weeks. And the midpoint is 25 weeks because 50 weeks is a period. Last but not least, let me label my y-axis as well. I mean our vertical axis. And in fact, we don't have to rush to label our y-axis first. What we need to do is we should label the points for our basic cosine graph. So as you can see, I always start with my basic cosine graph and adjust accordingly later on. So I have drawn my basic cosine graph. So y equals to cosine t. Or in fact, I should use p equals to cosine t because my vertical axis is p now. And my basic cosine graph, what I'm doing now is I've added in my 50 there. Not only this, I know that I have to add in another 900 because my c will increase my each value by 900. Therefore, from 50 I get 950, 0 I get 900, minus 50 will be bumped up to 800, right? Will be bumped up to 850, and my 0 will give me 900, my 1 will give me 950. So now let me link up these points. And the second curve will be my p equals to 50 cosine bracket pi over 25t plus 900. So as I told you before, the only curve you need to show is your last curve. Okay, so I hope you know how to draw the curve from your basic cosine curve. So I have erased accordingly. Okay, now we are asked to find the maximum and minimum value of p. So it's obvious from the curve, our maximum is 950 thousandths. Our minimum is 850 thousandths, because you should note that p population is in thousands. Okay, so don't forget. Okay, last, estimate the number of weeks within the year that the population is less than 915,000 and give your answer correct to the nearest whole number. So what it means here, it means let's equate this p to 915 thousandths. So therefore, your left hand side is 915,000 equals to right hand side equals to 50 cosine bracket pi over 25 t plus 900. So let's go ahead and solve for t. And you should get t equals to 10.1 or 39.9. Over here, I'm not going to go through again how to find t, but you should know how to find t from previous examples. And therefore, the number of weeks is 39.9 minus 10.1. So therefore you get 30. Number of weeks is 30 weeks. Okay, so we have finish this chapter. I hope you have enjoyed it, but there is an excitement here. Go ahead and do it. Hope to see you again. Bye.